Hey guys, welcome to another video, and we would be continuing with organolithiums. This is the second question in the series question of the day, and I'm very sorry right now I do not have the time, so you would not see the options, or you'll get a much better practice with the options. But this is also a great way to test your knowledge. If you don't have the options, then still you need to predict the answer over here. Okay, so last time we studied about sulfur lithium exchange. That was a comparatively new topic, and little bit we also discussed about chelation. Now over here, let's first try out the question, and then I'll tell you what concept we are going to be studying today. So now if I to this particular molecule, let's say if I add tertiary butyl lithium, okay, at very low temperatures, obviously, like I said, organolithium reactions we conduct at low temperatures. We'll have some solvent. I'm not mentioning it. It could be THF, tetrahydrofuran, okay, or any other solvent, and you will get some intermediate. And then after that, after we have that intermediate, let's say I run this reaction at 20 degrees Celsius in presence of methanol as a solvent. Okay, so what do you think is going to be the answer? You can pause this video and try and figure out, and then I'll tell you what the correct answer is. So the question would be, what is the major product? Okay, there might be certain minor products. So now I hope you have paused the video, got an answer. So let's look at the correct answer for this question. Double bond over here, and then this attack takes place, and then so basically a methyl group over here. Okay, I'm very sorry, I'll just please excuse my drawing. So we'll get a methyl group. So we'll get a 5-member ring basically. And what is actually happening is there is a sort of like a halogen exchange, okay, a lithium halogen exchange. So you'll get the lithium over here, and you know that whenever there's a lithium bonded to a carbon, it is you can, like, obviously it's not an ionic bond, but like it's not anionic, carbon is not anionic per se, but you can basically think of it as a negative charge on this carbon because this bond is highly polarized. So you'll have a, like, if you consider we have a negative charge over here and we consider it as an anion for the simplistic scenario, then this has two places where it can go and attack. Either it can go and attack at this carbon, or it can go and attack at this carbon, right? So if we attack over here, we'll get a 5-membered ring. That this is the major product that we have got. And if it attacks over here, we'll get a 6-membered ring. Now it might look to many of you like a very easy question, but I'll make it a tad bit difficult. And so there are two possibilities. One is the 5-membered possibility, and one is a 6-membered ring possibility. So please remember this, again, a very, very important point, that your organolithiums, okay, they always prefer formation of 5-membered because the conditions are kinetic in nature, and 5-membered ring is much more kinetically favorable than a 6-membered ring. Thermodynamically, it's very hard to differentiate between them, but kinetically, yes, a 5-membered ring is definitely more favorable than a 6-membered ring. Okay, now, so please remember this. This is a very, very important point. Be it alkyne for that matter, be it an alkene. If there's a carbon lithium bond that is gonna be formed, it is gonna basically prefer a formation of a 5-membered ring over a 6-membered ring. Okay, that is a very, very important point. And how it is, this particular reaction is very useful, is that you can basically, if you add to this, let's say if you do a radical reaction, same reagent, okay, instead of like you can remove the lithium. Let's say we'll remove the lithium. Yeah, so same reaction, if you have iodine, and now what I do is, if I add your radical initiator and radical propagator, right? So if I add this a radical initiator and radical propagator, so basically what I am doing is a radical reaction. In this case, the major product that is formed is a 6-membered ring. Okay, so how do you actually go about the rules of such reactions? Well, they follow the Baldwin's rule. Okay, they follow the Baldwin's rule. I will show you the Baldwin's rule over here. Many of you might already know about this. In fact, you should know about it, the Baldwin's rule of cyclization. So if you see over here, if I talk about, so what are the two cases over here? If the radical is forming here, then it can either attack this. So this will be a 6 endo trig reaction. So this double bond will be considered a trig. So 6 endo trig, and if the reaction takes place over here, this will be 5 exo trig. So 6 endo trig and 5 exo trig. So 6 endo, that is also favorable, and 5 exoteric, that is also favorable. So you can see both of them are going to be favored over here. That is why if you talk about a radical reaction, in this case there are certain other points also to be considered, and I don't want to make the video very complex. So like but it is very difficult when both of them are happening. So if you have a radical reaction taking place, there is a very strong competition, even though this is the major product, but there will be some minor product found with the 5-membered ring, which is this particular case, right? But in case of organolithiums, in particular case of organolithiums, this is the major product, like by far the major product. So that is why I introduced this topic, because I haven't seen a lot of cyclization reactions in the examination. So maybe it might be asked, or because a lot of you do not practice cyclization reactions, again because of the dearth of questions. So that is why I thought of bringing this question. So please remember, cyclizations in organolithiums are particularly favored for 5-membered rings. So right, there might be certain exceptions if there is a very different substrate, or there is some kind of steric hindrance, obviously that you need to consider, but in majority of cases that is the case, that is the answer, right? If somebody tells you all the time, I am pretty sure I can say with a lot of surety again that they would be they are not half as knowledgeable as you think, because honestly in science, let me be very frank again, it's a question of the day, but then you cannot be 100%. Okay, that's how science works. There is always scope of improvement, there's always a scope of doubt. Anyway, so this is the reference if anybody wants to go ahead and read the research article and have a more in-depth understanding. Coming to something called as cascade cyclization. So again, we let's if you understood this concept, okay, so let's try and execute this particular reaction also. So same conditions, we are adding tertiary butyl lithium over here. So we'll add tertiary butyl lithium, and we will add at -78 obviously, and means at low temperature, not exactly -78, could -100. You get the point. And then this is the first step, and then some solvent, and then we add methanol as a proton source at 20 degrees Celsius room temperature. So let's see if you are able to get to the correct answer for this question. The hint is that it's a cascade cyclization. So I hope you understand what this cascade means. So this is your cascade cyclization. Okay. So anyway, I hope you have paused the video and drawn the structure. So let's look at the first case. First case is obviously a lithium halogen exchange, so I can just draw lithium over here. I told you it always favors 5-membered, even if it's a 3-member, even if it's a alkyne over here. So we have 1 2 3 4 5, so it will attack over here, we'll get a 5-membered ring. So let us quickly draw a 5-membered ring. Yeah, so we have a 5-membered ring, and then this will, once the attack takes place, so let's say if I go this attack takes place, this will form a double bond with a negative charge. So we'll have a double bond, and then obviously this ring will continue. So if you think about it, this is my carbon number 1, this is 2, this is 3, this is 4, this is 5, and then there's a 6th one. So from here again I'll draw 6 and a double bond over here like this. Okay, and then if you see over here, there's a negative charge also formed. So if you consider this as carbon number 1 or 1 dash, okay, then there is a negative charge, because once the attack of this carbon number 1, the one in red, takes place, okay, you can see that there's a anion formed over here, right? There's an anion formed on carbon number 1. So this anion will be attached to the lithium, so we'll have a lithium over here. Okay, so let me draw it in black. We will have a lithium over here. Okay, so obviously I cannot draw a bigger one because it will look like a bond, but I hope you got the point. There's a lithium attached over here, and so then this is what is going to be formed. So again, let's look at it. 1 2 3 4 5, so attack takes place over here, lithium gets attached, and then we have 1 2 3 4 5, and then this is my 6th one, right? So this is my 6th carbon. So you can see 1 2 3 4 5, and this is my 6th carbon, right? And now you can simply see what can happen. Again, a 5-membered ring will be formed. So again, I can show the attack of this onto this, right? So we'll have 2 5-membered rings. So it will be like a fullene system. I don't know if you have heard about it. So this is going to be our final product. Okay, so I hope you found this video informative. Again, this particular reaction is very, very versatile. It can be used to draw some very rare substrates. For example, this reaction can also be used, like this cyclization reaction involving organolithiums can be used to form cyclobutanes also. So let me maybe quickly give you an example somewhere over here. So if I have something like this, so you can see if I label it, this is my carbon number 1, this is my carbon number 2, this is my carbon number 3, this is my carbon number 4. If I add to this again my tertiary butyl lithium, and then in the end add methanol, so you can see that again lithium will attach, so lithium halogen exchange will take place, and then this is gonna go, so we can write lithium, and this is gonna go attack over here, so I'll get a 4-membered ring, a cyclobutane basically, and then double bonded over here to some R group. Okay, so this is going to be the case. Okay, because we are adding methanol in the end, so first lithium will be formed, obviously, because the anion will be generated once this bond migrates over here, and then your methanol will basically act as a proton source, and that is going to exchange with the lithium. Okay, and then we'll have the hydrogen over here. Okay, so this is going to be the product. So this is how this particular cyclization reaction can be used. Either for simple cyclization to get a very, very specific product, or for cascade cyclizations and to get some very rare substrates, like in this case the cyclobutane. So thank you so much for watching. If you like the video, do give it a big thumbs up. Please share it with your friends, because again, that is something that does really motivate me to make more videos and more frequently, right? So yeah, that's about it. Thank you. Take care. Bye.